thank you for the kind introduction. And unfortunately, I have to disappoint you. There's no Shindy or no Bushido as cover song. It's just, I couldn't decide about the title, so it's Drums and Croissants. Who of you likes music? Some of you, that's nice. So, do you know the situation when a friend shows you some masterpiece of humankind which really touches your soul and you're so overwhelmed by the art and you really like it and you can't think to something else than this masterpiece? Do you know the situation? But I want to stick to Donald Trump. I'm really fascinating about him. I even have pictures of his bathroom, as you see here. That's the bathroom of Donald Trump's golf resort somewhere in Florida. And you see a lot of boxes. Do you know what is in these boxes? These are top secret documents, governmental documents from the US government. And he stores it in the bathroom because the bathroom is safe. You know, always when you feel afraid, you go to the bathroom, nobody else is there, it's a safe room. But maybe for some things like top secret documents, it's not the best place to store it. So I want to talk with you about information security, because we're living in times where we have internet. Not everyone knows this in governments, but we have. And up to now, we encrypt with certain protocols our information to protect them. You know this from email clients, from online banking, and so on. But there are new technologies arriving, which makes these protocols not usable, and so we need new technologies. So the buzzword is quantum and AI and blockchain and so on. And what I want to talk to you about with you is quantum-powered cyber attacks and quantum-safe encryption and so on. And to do this, I don't want to go into details, just accept that it's important. We need single photon sources. And to produce single photon sources, we have to talk about croissants and drums. And yes, that's about my slam. Yes. What we are doing in our research group, we more or less build music instruments, very tiny music instruments, and especially me, I'm building drums. Drums, why? Because we use two-dimensional materials, so-called van-der-waals materials, which can be used as single photon emitters. And this is really cool for quantum communication. And now you maybe think about, okay, what are 2D materials? What is this? Basically, this is a very thin layer of material, just one atomic layer. And then some strange people sitting over there, the Hollies, hello, props to the Holländer group, they can shoot out some atoms of these membranes, and then you have single photon emitters. And this is really cool. And yes, now you maybe think about, okay, how do we get these very thin layers of material? And I don't know, as you know, croissants, if you take it, it's really bulky and thick. But if you crumble it, you have really thin layers, which are quite of reasonably big surface. And basically, that's our research, making croissants and building materials. So what we do, we have materials, so-called, for example, transition metal decalcogenides or HBN. Van-der-waals materials which has strong chemical bonds in one layer, but very weak bonds in the other direction. And so we can get very thin layers, like in the croissant, and out of this, we can build drums. So what you see here is just a silicon oxide or silicon nitride substrate with holes. We put the flake on it, and then we have a drum. We can play with the drum or not. And basically, that's our research. So some of my colleagues, they build strings, harps. So Felix is sitting there. So in Cornell University, they build guitars. And I, like Richard Feynman, I build drums. Yes. And now we want to use this for quantum communication. But there's one. Yes. And do you know the new electrical engineering building? It's really cool. It's really nice. It's in TUM campus, and it's brand new, super cool. I will come back to it in a minute. But to build the drums, back to the drums, we are living in reality, unfortunately. And reality is like modern music. Sometimes you want to have perfect systems, perfect drums, perfect sounds. For example, you maybe want to play the violin, but you just are able to drum on the violin. So, like in modern music. What we like to have is, we want to have a perfect appearance, a perfect instrument, and boring sounds. And that's not what we have with our flakes, because you see, the flake is a bit crumbled, it's not really perfect, it's very small, and basically we want to improve it. And also sometimes when you fabricate it, things happen like here, so it's our brand new building, and there was stamped a layer of some lattice, whatever, and it break down because of snow, I don't know. And sometimes it appears in Munich, but architects don't know. And the same thing happens also with our drums. So when we want to fabricate them, it's not so easy to really keep them alive. Let's say it like this. Yeah. Back to the sound. Do you know what this is? Any guess? Any guess? Yell it. Music. Which kind of music? Taylor Swift. No, it's it's a trumpet. What you see is you have some harmonics. We have quite a cheap instrument, and you can get really nice harmonics, really nice spectra. And what I have after days and weeks of lab work and research is this. So, and I want to conclude with this. So, research is hard, and sometimes your results are not so nice, but you can always pack them in music, and then it's nice. And yes, hope you enjoyed, and enjoy the evening.